All right, Rich, how are you doing?
I'm doing well, Steve. How's it going, man?
I'm doing well. I'm calling in from Dubai. Nice sunny Dubai, but
Yay.
it's late here. And
We're
where
here.
are
We're
you?
here in rainy Seattle.
Rainy Seattle. Excellent. Good. Well, welcome everybody that's on. If you guys can just drop in the chat, whoever's joining us here on LinkedIn, tell us where you're calling in from, because we're going to have a section on question and answers. So it'd be great to hear from you. Today, we're actually going to be talking about some really interesting stuff. We'll be talking about Deepseek, and I know a lot of conversation has been going around on Deepseek. I think, Rich, last month you and I met, and on here we had a LinkedIn Live, and you had brought it up, but then
Yep,
ever
that's right.
since kind of the news broke and everybody found out about Deepseek, now everybody wants to kind of talk about it and hear about it and understand it a little bit better. So I was thinking, hey, why don't we use this as a topic today to really understand, the technology, understand what's going on, and who better to cover that is yourself. So, actually, Rich, why don't we start with you? Maybe if our audience hasn't heard who you are, it would be great to kind of hear a little bit about you and your background.
Oh, no problem, Steve. So my name's Rich Tong. I worked for many years at Microsoft. So I ended up running the product management groups for Windows and then all the enterprise products in Microsoft and then Office. So I knew a few things there. And then I spent 15 years as a venture capitalist, both here in the US and then also in Asia. And as you know, 5 years ago, Steve, I just got to be part of this AI revolution. So we started one company, which we sold, and now we have another company we're in partnership with you on called Total
Yes.
Neural Enterprises, which has been great.
Yes.
And of course, Horizon X, which is one of the most wonderful things I've ever been involved with.
No, it's actually really exciting. And I think, part of, I assume that everybody knows who I am because they're dialed in, but just in case if you're new and haven't heard about us, we're Horizon X Consulting. We're a consulting company that specializes on looking at emerging technology and innovation and how we can help our customers really think ahead and understand how to deal with innovation. I mean, innovation seems like a very easy thing, but there's a lot of opportunities for us to help out. And the way we're broken out is by different horizons, which is why we're called Horizon X. In Horizon 1, we really help people focus on incremental innovation. In Horizon 2, it's really about bringing new innovation to your organization. So bringing technology that already exists into your organization. So this is where Rich and the team come in, is where they're really specialists on AI, and they're really pushing the needle on how they can help organizations using AI to make a big impact. And then the third the third horizon is around quantum computing. And that's where I like to spend a lot of my time. I actually do a lot of posts on, and that's about more disruptive innovation and things that don't exist in the world. And obviously, with a lot of the news lately coming out of Microsoft and Google based on their advancements, there's a lot of attention on it. But for today, we're going to be focused on Horizon 2. So we're going to be focused on AI and Deepseek, and hopefully we'll have people there asking questions. It would be great, again, in the chat, if you can, just tell us where you're calling in from. I can see Charles is calling in from California and others. So do let us know where you're calling in from. Anyway, so before we kick off, Rich, do you want to make any comments about Deepseek, or should we just jump into the presentation?
You might as well just jump in, get to it.
Excellent. All right. Hopefully you guys can all see the presentation. So I'll let you kind of get going, Rich.
Okay, well, since this is the new media, I thought I'd just start with what we're going to talk about in a nutshell, which is that you can think of Deepseek as the poster child for what some people call AI time. There was an old term called internet time, which was moving so fast that it was unbelievable. And AI time basically means last night I was up reading and 3 more models shipped in the last 24 hours. So DeepSeek is just one more example of what we think you have to expect, which is just massive changes. And having done this little job for 30 years, I tell you, there's a lot more coming. I guess the second message is all of the stuff about AI is really great, but the really hard part is the elephant in the corner, which is making AI reliable is really hard. And when we talk more about DeepSeek, you'll see that you're going to have to switch between different models. There are these things called agents. We really need an AI Windows that takes care of all these problems of safety, privacy, writing software, scale, and learning. And just so you know, that's why we built our little Orion AI operating system, which basically is a core to let you integrate things like DeepSeek. And just to get to the applications, then only then can you get to we call it a process suite, a P suite, that's sort of like the AI office for all CXOs, where you can capture all your processes from sales, service, and production. So DeepSeek is a little bit like the beginning of a long journey to get through this horizon, and it's not going to be easy. Question, Steve?
No, just trying to kind of understand and how it all kind of fits together, and maybe just, and I don't know if you're going to do this now or later, is a bit of history about DeepSeek. How did it come about?
Yeah, we'll cover that in a second.
Excellent.
We'll cover that in a second, no problem. Yeah. So the thing I want you to not feel bad about is this is a chart that shows how long it takes for various innovations to happen. The spindle, which was the sewing machine, took about 130 years. If you look way down in the bottom, internet time was incredible. It took about 2 years. AI time is basically about 23 months. So what's happening is super fast, super hard to understand, so don't feel bad. Next slide. I just want to tell you it's getting worse. So these are the statistics for the number of new research papers published every month. So there were over 10,000 papers published in the end of the year. Just to give you a perspective, in 2005, there were less than 200 or 300 papers published. So every day literally brings something new, and DeepSeek is sort of the new hotness.
And what's causing, I guess, Rich, before we move on, what's causing that? Because obviously you see a huge spike up, and I'm only assuming it's only going to get even more exponential, if you will.
Yeah, what's causing it is, over the last 5 or 10 years, we've learned how to do open research. So instead of things being hidden behind firewalls and things, you're seeing people talking about it, even publishing software that runs it. And let's face it, the world has gotten to the place where everyone can be a researcher contributing things. So it's really, truly a global phenomenon.
Excellent.
Yeah. So I just want to tell you what and I just counted up Steve's last 35 years have taught us. So Steve, you're up here on the upper right as, for me, the ultimate user and innovator of technology. The other folks in our little company are equally excited about it. But Paul Moritz, for instance, was the CEO who took VMware public. Then he took a company called Pivotal public, made about $50 billion doing those IPOs. I'm down here as just the smallest person, but the team, we've learned a lot of lessons. And when you have innovation this fast, you've really got to think about what might be happening. And that's really what we've been up to. So if we go to the next slide, I just want to show you some of the lessons learned, which are really all shown in DeepSeek. So this is sort of the history of my life, which is the era that I lived, the wave that I was part of, the leaders that I learned from, the projects we've learned on, and the lessons. And what we're seeing in the internet revolution is all these lessons playing out again. So in the beginning, with a PC on every desk, was really about a small number of people. Unit quality really matters. Whether you're in the Army or in the software group, a small number of great people can do amazing things. And that's really what DeepSeek is about. The second is about earning trust. So being reliable and being able to run things properly. And I think that's where we are really stuck out as an industry with AI. Now, the smartphone revolution, which I was part of, and I'm very happy to say, I learned a couple of things. One is where things are happening really matters. This DeepSeek phenomenon is not just about China or about the US. It's about everyone on this call in every country in the world. And the year of 2016 was really about the open internet and how hard it is to compete. In fact, the software you're using right now, Steve, all based on open source software. Everything that we're using is based on open software, which is very strange that something that's given away free is the most valuable thing. And then I was part of what I call AI ancient history. So back in 2014, we started a company focused on vision, and computing. And I would just say the biggest story about AI that hasn't happened yet is that it's all going to run in your PC on your phone eventually. And having vertical expertise, and most importantly, this open research is really important. And that's what really Deepseek is all about.
No, I think it's great, Rich. And I think the part, and this is why I feel very lucky to be working with you, is that you obviously have all that history working at Microsoft, understanding how things integrate into different operating systems, how people behave behind the computer, and then taking that knowledge and then bringing AI to make the knowledge workers more productive, I think is fantastic. And that's some of the work that I saw. That's why I'm very excited, kind of getting into 2025 and what we're going to be able to do from the AI side. And so I think it's great. I do see we have people joining us from Athens, from Paris, California, London. Anybody that hasn't chimed in, go ahead and chime in. But even more importantly, as we go, please start asking questions.
Absolutely.
And I can use those questions. And the tougher, the better, because Rich can handle the really tough questions. So,
well,
and
hope so.
Any math involved, I'll make sure I'll pass it.
Yeah, we can work on Fermat's last theorem here. No problem.
All right.
Okay. Here's what I wanted to explain is when this whole thing started, this is a chart that was actually from May of 2023. And basically, if you look up the upper left, you see GPT-4. This is a rating system. It's like chess. At 1,200 points is really good. If you're 100-point difference, the better model, 100-point better, is basically beating the small one by about 65% of the time. So it's not exactly a big win, but it's significant. But if you look at this chart, there's a funny thing. You see this thing called Vicuna 13B. So This is what's called a 13 billion parameter model. This model is 100 times smaller than GPT-4, yet it's super competitive. And that was one of the crazy things. And someone at Google wrote a memo that was entitled, "We have no moat and neither does OpenAI." And in many ways, it was poo-pooed at the time, but very propitious about what's happening. So here's what they said. While our Google models still hold a slight edge in terms of quality, the gap is closing astonishingly quickly with open source models. And they make a very important point. Giant models are slowing us down. In the long run, the best models are the ones which can be iterated upon quickly. We should make small variants more than an afterthought. And most importantly, you just can't beat the internet. So let's move forward. Let's move forward a little bit and see what happened. Any questions about that?
Yeah, I guess, Rich, on this thing here is obviously when you got these small models that are competing against the OpenAIs, Microsoft, I don't know how many billions did they spend on OpenAI?
Maybe 10 billion.
Yeah, exactly. And then Google working on it. If they're not creating moats and other people are coming in, what's the opportunity for the people listening to this call? Or are you going to talk about that later? I don't want to steal your thunder.
No, not at all. I mean, you have to remember, most of the world uses Android, right? From Google, it's open source. So you just have to remember that you can build a gigantic ecosystem and be a leader. Linux, for instance, billions and billions of dollars have been made. VMware, everyone made money on Linux, and everyone's making money on Android. And so the key thing is you want to be part of the innovation, global innovation, not be locked into a proprietary system. And my early career was all about proprietary systems. And man, I learned that religion by 2000. You just got to be part of the open stuff.
Yeah. Okay, excellent.
So let's fast forward a little bit. Let's fast forward 18 months and see where we are now. So let's take a look at that. Next slide.
Yeah.
By the way, that was synthetically generated on my laptop last night.
Is that
okay? Go back one, Steve. Oh yeah, no, this is it. Thanks. Sorry, forward one. Fib 6. So this is the beginning of this month, and here's what happened. You see all of these models on this benchmark. They're all essentially identical. They're within 100 points of each other. Wow, that's crazy. You see on the upper left that Deepseek R1 is at 1320 points, almost identical to GPT-01 and to Google. So guess what? That Google guy was right. And in fact, half of the models developers on here are not in the United States. 4 of these models are totally open. You can use them any way that you want. And the one on the right, actually runs on your PC. And I would just comment that we've been talking a lot about Deepseek, but what the heck is a step fun? or a zipu. And so in fact, there's a lot of innovation going on around the world around models. So yeah, it doesn't look like there's much of a moat.
Yeah, and it seems like there's new models every day. I mean, I'm hearing about different names, and I think you made a comment at one of the LinkedIn lives we've done. By the end of this live, LinkedIn Live, there'll be X new models out there published.
That's right. There's literally there'll be probably 10 or 12 new models published in the time we do this LinkedIn. And there's probably about 200 research papers that will have been created by the time we finish this call. So think about that for a second. Let's go to the next slide and talk about today.
Yeah,
so
yeah,
I couldn't, yeah.
I'm just surprised at the level of innovation, how fast things are moving. And how do we keep up? But go ahead.
Yeah, no, I mean, keeping up is one of the key things, and having the right software on top so you're riding along is very important. I just want to show you, I did this last night. And so now 6 out of the top 11 models are now out of the US. So we've actually broken the greater than 50% non-US models. 5 of the top 11 are now open. And here's the interesting thing. If you look at look at that first bubble, these are the top models. They're all within 20 points of each other, which basically means they're identical. So we're talking a lot about how great these new models are, et cetera, et cetera. Really, everyone is about the same.
Yeah.
The second thing is, if you look at the next bubble, which says Deepseek V3, that's their old model. My gosh, that's within 50 points of their best model, which is Deepseek R1. If you look on the right, you see at number 26 is Deepseek V2.5. Yeah. That's 1240. So in all of this time, although there's been all this innovation, essentially we're not moving very fast. In fact, the best model moved about 27 points over a month. So what that means is we've really hit some plateau. And what Deepseek is really indicating is that plateau is pretty darn good and it's free.
Yeah. Well, and I think that was going to be one of my questions is not all models are alike, right? So you've got some of these models at the top of the list, but how much does it cost to run those models?
Exactly.
How much did it cost to train and develop those models versus what's coming in now?
Yeah. And I think that's one of the big messages. Remember, Deepseek is 2 things. It's a service you can use. It's also an open source project. So literally there are 100 companies now that have taken Deepseek and already turned it into their own. In fact, anyone on this call can run Deepseek, can monitor it. It never goes to the public internet. It's just your model. And that's the thing that open research and open models provide.
So let's kind of dive in a little bit on that, Rich. So let's just say anybody on this call, I want to download it. So you'd go down, there's a special one that you do want to download, right? I believe it's from my school at MIT.
Yeah, that's right, that little school there.
Little trade school that you call it. You want to?
Well, I went to the junior university on the other coast, so it's not like it's any better.
No. Stanford does very well for itself. So tell people on this call. Let's just say they've got that big MacBook that you have, and they want to run it. So what would they do? They would just kind of go to the web.
They would go to the web. You install literally one piece of software on the Mac. It's something called LM Studio or Open Web UI. These are all free products. And you literally just say, please give me the latest model, and it'll download it. By the way, this can run on a 16 gigabyte, $1,000 MacBook Air. It can run on I actually have it running on my Linux notebook that's cost about $1,000. So you don't need a big machine to run these things. And that's really one of the remarkable facts, that it's just available.
So it's funny because when I'm on a plane and I don't have internet, I definitely start missing some of the chat GTP applications, because then I could see how unproductive I am, how much I depend on it today. But when I'm on a plane, I can't use it, right? So are you saying I can download this, use it on the plane, just like I'd be having full internet access?
Oh yeah, absolutely. In fact, I just flew back from Singapore, which is a great trip, and I was generating new images for this presentation. I was asking questions, all on your laptop, all private. The next generation of models will just run on your phone. So this, effectively, large language models are about to become invisible because it's going to be in every device you have. You don't have to rely on a big cloud provider, pay millions and millions of dollars in fees, and most importantly, your data is private, which is really important.
Yeah, and I think that's going to be the key, right? I think we'll get into kind of the concerns or things that
Yeah.
I've been reading about around privacy and all that other stuff down the road. But I think if I can start generating this from my laptop that's not connected, then we talk about the energy use and the tokens and all this. I think that's pretty powerful. The fact that I don't have to go
Oh,
out to
absolutely.
online, use
Absolutely.
resources and the sign. And I think even if we have a conversation around ESG, the environment and sustainability,
Oh,
I mean,
it's huge.
why why would I run a big model that kind of takes everything on the internet, like what the Kardashians are doing today, and use that when I don't really need that, right? And it's kind of funny. I
Exactly.
think I probably stole your line because the first time I heard you talk about it's like a model that knows what Taylor Swift's doing and all that. So
Yeah,
yeah,
absolutely. I mean,
go ahead, Rich.
no, I was going to say there's no reason to carry all that junk around. Let's just have models that are specific for your purpose, and there's so many of them. So the real lesson of Deepseek is you got a lot of choice. And the second thing is you have to be flexible enough that you can use any of these models whenever you need them. So as a corporate customer, this idea you want to be locked into a single vendor, it just isn't necessary. You want to be multi-vendors. Steve, HSBC was never single sourced, and these models are the same way.
Yeah, you don't want to have any dependency. And that's actually a very good point, is that by doing this, you kind of try the different models and you don't have a single dependency on anything, which is great. Let me just take, I'm calling it a commercial break. So Rich, before you move on, tell us what you can do to help people take advantage of this whole small models and how they can apply it
Oh,
to what they're doing. It's kind of like our commercial break or
yeah. Yeah.
giving our sponsor an opportunity to kind of talk about what they do. And then we'll go back to educating everybody on Deepseek.
Yeah. No problem. So I think, Steve, you and I and the rest of the group have been in partnership. But if you have any questions about how to do this, just give Steve a call. Horizon X is one of the best consulting firms. We're doing the backing technology that we can use to implement these things. So we're working together as a product company, working with Steve, who understands transformation to make this all work. So literally just flip us mutually a note, talk to Steve, and you can be on your way.
Yeah. And so I think that's what I kind of want everybody to know about. This is something that is done real. Rich has got the background and he's got the engine that knows how to do this. And that's why we're very excited to be partnered up here. So let me go ahead and go to the next slide. All right. So here's the Deepseek slide.
Yeah, well, okay, so let's talk about Deepseek and what it is. And first thing I want to make a comment on is people talk a lot about artificial general intelligence or when machines are just going to take over. I guess I'm here to tell you it's not going to happen probably this year, but I'm probably right or wrong. No one really knows, but this is definitely on the path. I think the way I think about this is Deepseek, like everything else, is just a really good way to make computers work for you. So we are quite a bit away from machines that can just think for themselves, but we're getting on the path. And there are really four things that Deepseek shows. And I just want to comment, in the time that we started talking about Deepseek about a month ago, there have been at least 3 seismic shifts that have happened and maybe another one overnight. There's something called S1, there's Small Thinker, there's Perplexity R1. There's so many things happening. And the key thing is, this was all what's called open weights and open research. So Deepseek is publishing what they did. You can look at it on Hugging Face, you can get everything you want. And then you can just download the actual software just on GitHub. In fact, they're outsourced. They're showing you everything about it. The second thing is, it looks like they trained it with 100 times less resources than, say, Llama 3, which is one of the big models. So they're much more efficient. I don't want to go through all the details, but essentially Deepseek, it is a very large model with 670 billion parameters, but they have so many tricks to make it run super fast. And the third thing is there's the state-of-the-art thing that's happening, which is how you train it to do better. And they basically were able to do it completely automatically. And as I said, the last thing is 95% of this can just run on your PC. So they did something called distillation. So there are 3 billion parameter models that can run on a phone, 7 billion, 14, 32 billion. What this means is all of this can be accessible to you. And just to tell you a little bit about S1, someone in Berkeley, another fine school, figured out how to do everything DeepSeek is doing for about $50. After DeepSeek came out, they're like, oh, I can make that work with any model. So it's happening, man.
That's amazing. I think that's kind of the creativity and ingenuity that kind of makes breakthroughs. And I think this is kind of in the quantum in the quantum industry. These are some of the things that are really going to make things happen. Is you get people that come, they find a solution, they crack it, and then somebody else builds on top of that. And so it's kind of like standing on the shoulders of giants and making this happen. It's actually really excited to be seeing this real time. So, I mean, there's a lot of stuff. So let me, Rich, I'll ask you a couple questions. Sure. And again, I'll remind everybody, ask your questions on here and I'll make sure that I can ask them. But some of the things that I hear is, oh, DeepSeek used some of the large language models to really train itself. It didn't just train itself for $5 million.
Oh yeah, of course. Yeah.
You know, it did that. So from your viewpoint, is you think that's kind of what happened?
Hey, Steve, you're an athlete. You know, I do a little exercise. You know, you didn't make your own shoes. I mean, they had to start from somewhere. So the key thing about open research and the open internet is everyone uses everyone else's to basically, we're always standing on someone else's shoulders. So DeepSeek isn't possible without all the other innovations. And by the way, the next versions of DeepSeek, like Perplexity R1, is actually based on DeepSeek. It's actually DeepSeek customized. So that's the power of openness, is that you can use someone else's tools, you improve the tools, and then you give it back. We in our company, tne.ai, we're constantly giving back to the community, and millions of other people are giving back to us. So that's really the trick. So there's nothing wrong with saying you're based on something else, because that's how the internet works. It just builds on top of each other.
I love it. It's kind of like Picasso. Picasso used to have this famous line that says, great artists, good artists copy, great artists steal. And so everybody's kind of stealing off of each other and learning, but obviously they're making it for the greater good. Will you get into kind of the cost side of it and the privacy side of it later?
Oh yeah, I'm going to talk about that right now. So this is in the more efficient part. So basically one of the things they did was the training cost was 1/10 of what's required. But and this is a little bit technical. It's a 671 billion parameter model, so it requires about 600 gigabytes of memory, but only 37 billion are active at any one time. So that means that its energy use is basically about 1/20th that of conventional models. And so that means that's why you can run it on your phone. It just doesn't do it. It basically figures out what to do, and they are very clever, unbelievably clever about doing all kinds of specific things: multi-headed attention, token predictions, mixed precision. There's a lot of just really good engineering to reduce the cost of running these things. And in fact, DeepSeek cost a massive price compression. When they first came out, they were literally 20 times to 50 times cheaper than OpenAI, and OpenAI has had to drop their prices. So remember, competition is good for all of us.
Yeah, no, without a doubt. And I think that goes along with kind of what I see John is asked the question. John's out of Dubai, actually. I just saw him earlier today. And he's talking about, does DeepSeek have an impact to future data center usage?
Yeah.
They're creating a bubble.
Yeah, well, that's, you know, I'm not here to advise people on stocks or anything, but let me just say, if you just project exponentials, you know, in this business, Steve, you say you got 10 servers, 100 servers, 1,000 servers, it doesn't mean HSBC will have 40 million servers at the end of 3 years. Yeah. So just beware. A lot of the predictions in the stock market are just what's called straight line. If you're doubling every year, you're going to double every year forever. That's just not the way it works. So yes, it could potentially have a big impact, because basically human brain power, we're still important, is so smart about making things more efficient. And that's what's really happening here.
Well, and I hear, you know, look, you're making it more efficient. But then what I'm also hearing is that now we can apply even more resources. And so the prediction is we're not going to use less energy now. We're not going to use less data centers. Now we're going to be doing bigger problems, and we could do even more. It's just going to be a lot more efficient.
Yeah, I think you're totally right. I would make one comment. There was an idea about a year ago that, you know, OpenAI is rumored to have a $10 billion data center, and then they're building $100 billion and $1 trillion single data center. One of these things could mean, it could mean is that you don't need $1 trillion to even build a model. You can do it in your garage, for instance. So it's probably going to spread things out a lot more, which is good for everyone, because we don't want there to just be one big factory where only one model comes out. That's not good for the planet.
No, of course. And I think it's good. Like you said, it's good to have competition. It's good that everybody's competing against each other and that we're making it better. So I think, you talk about, and this, we're not giving advice. It's not, do not take anything of this as financial advice, but it was interesting that as soon as this got released, billions of dollars came out of the financial markets because the guys that are selling the picks and shovels, all of a sudden they were like, okay, well, we don't need as much CPUs or GPUs or that kind of stuff. So
in fact, in the next slide, we're going to talk about that in the very next slide.
Sorry, I don't mean to steal your thunder. Go ahead.
No kidding. Well, I just wanted to show it graphically because it's hard to understand. So this chart shows the score of Deepseek in red, and then Google, and then OpenAI and Meta. And this is the actual numbers, right? They're all basically the same. On the left, though, is the number of GPUs they're estimated to have. So Deepseek has between 2,000 and 5,000 GPUs. You can't even see it on the chart, right, Steve? No one knows how many Google has, but it's probably about 750,000 GPUs, maybe 1 million or 2 million. OpenAI says they have 400,000. They want to go to 10 million GPUs, by the way. Wow. And Meta has about 662,000. Let me just remind you of something. Stanford, my alma mater, has exactly 1,000 GPUs. And it's not like they're a slouch or behind on research. All of Canada, by the way, the entire Canadian infrastructure has about 2,000 GPUs. My son's a postdoc there, so I know that number. So you don't need an infinite number. It just means the quality and quantity of people still really, really matter. Capital is not the only variable. So I think I have 6 lessons on Deepseek, and that is the most important one. Don't just look at raw hardware, having 100,000 of X to mean that much, because someone with 1% of the resources can be just as good as you.
Yeah. No, these are amazing numbers. And I think it does take me back to kind of reading some of the research on Deepseek, and they built it not on the latest hardware either, right?
Yeah. There's an export ban for the latest hardware. So they had GPUs that are half the speed. By the way, it's not like Canada or Stanford has the brand newest ones either. So you don't need the newest stuff to be researching. You just need to have Mark I brains that work.
So I mean, going to what you're saying, Rich, anybody here that wants to get involved, or they have young kids that are doing this, what advice are you giving them? Because you're saying, okay, look, there's an opportunity to get in there and write models. And so if it's, okay, let me ask from a business perspective, if it's all open source, free stuff, then how do people make money off of this? If I'm giving everything I'm doing for free, then what's the business model?
Yeah, great question. So Steve, actually the bottom of Android is open source, but people are making billions, if not trillions of dollars on it. And so the answer is you need a lot more than just a core model that's open to make it effective. So you've got to be able to integrate small, large language models together with big models for depth and reasoning. You have to have adaptive agents. You have all that stuff hooked together. And that stuff is actually going to cost you money. So you can think about this as the bottom of the system, right? The sneakers and stuff, they're going to be free, but building the track, learning what's important in a particular environment, that stuff is really valuable. In fact, Satya Nadella thinks that the market for enterprise software is going to increase by a factor of 10 because we can do so much more. And we're seeing this every day, right, Steve? We can do an application that would normally take years in like a couple of weeks. So that's the real trick. Yeah.
Which is crazy how fast and how adaptive we can be.
Yeah.
And just using some of this stuff, just seeing in real life what we're doing for customers actually is very exciting. I mean, it's exciting to the point that I'm like, this is crazy that it's based on outcomes. We can give people outcomes very quickly, leveraging a lot of this technology. And by the way, Theo, in Athens, I think Rich just answered your question, because I could see he was using exactly some of the words that you used in your question.
I have a cheat sheet here. Exactly. and I do want to comment about clinical studies and medical profession. So full disclosure, our oldest is about to become a professor at Duke with a joint appointment at the medical school and in the computer science department. I think the best things are about to happen in research, and particularly clinical research, because these models, these so-called injecting systems, can just burrow away for hours. They never get tired. They're going to be the best assistants in the world. And it is very likely we'll see many, many new medical innovations by using these sort of agentic systems.
Amazing.
Yeah.
Amazing. And
Well,
congratulations.
let's go. Yeah.
It
Let's go to the
doesn't
next slide. Yeah. Okay. I just want to give you a view, because lesson 2 is you can beat guys with a lot of money with open research, because beating the internet is super hard. So this chart shows those same scores on the right, and on the left is the number of people working on them. So first of all, in the open source community, no one knows how many developers are working in the open source community. The best guess is there's probably 22 million people burrowing away right now writing software for the open internet. If you take all of Google, so every salesman, janitor, cook, and bottle washer, they have about 183,000 people. If you add OpenAI and Microsoft, they have about 230,000 people, and Meta has about 67,000. That is why it's so hard to beat the internet. 22 million people squirreling away, trying to make these things happen, is just a lot of horsepower.
Yeah.
I do want to comment. Someone asked about when we're going to get to AGI. It is probably, this is very controversial, it's probably true this alone, this LLM stuff alone, is not going to get us to sort of general AI general intelligence. And Jan LeCun, who's one of the big thinkers in the field, says it's really just a great way to write a lot of software, but it's not quite there yet. But 22 million people working away, maybe we'll get there soon.
Yeah, no, it's amazing. And I could tell you that in any industry, and especially in the innovation, the power of the crowd and knowing how to leverage the power of the crowd, because what happens is it doesn't matter how big your organization is, you can never hire people with all the different skills. And it's having that diversity of skills that actually makes things happen. One of the really interesting stories I remember was Pringles was trying to figure out how to make the right shape of a chip so that it wouldn't crack. And the guy that actually solved that for him, because they put it out to the industry, was a violinist. And they were using tuning and audio to figure out how do you create that shape, which I find interesting. So you do need people with different backgrounds looking at the same problem from a different perspective to actually find innovation. And when you have that many people, you can't. It doesn't matter how big your organization, you can't compete.
Yeah, So I think that's lesson 2. Deepseek is not really just Deepseek. It's about open research, and the open internet are kind of crushing it, and very surprisingly compared to 2 years ago. Next slide. Let's do some more lessons, Steve, eh?
Yeah.
Okay.
No, it's fantastic.
Yeah. So here's the big thing. It's not just these headline models. We've been talking a lot about Deepseek, but there's a certain, by the way, when you said, how do you get started? Go to walk, don't run to huggingface.co. That's the place where all the open innovation is happening. So last time this year, there were about 500,000 open source models where people are constantly iterating on the things that already exist. This year, I just looked yesterday, 1.5 million models are now available for anyone to download and use. Think about that, Steve. That's innovation.
Yeah.
And if you look at things like, by the way, if you look at what's the things that are going on, there's something called Local Llama, which is basically people who are interested in running things on the edge. That Reddit blog has blown up. It's gone from 100,000 people to 345,000 people. In fact, in the last 2 months, it's basically increased in size by 1/3 because everyone is interested in doing this. And I want to give one shout out to a fellow named Edward who probably is not listening. The reason this all works is something called LoRa. I can't get into the technology, but basically you can take Deepseek, you can, in 15 or 30 minutes on your laptop, run some training, and you can get your own role-playing model or SQL model or vertical model. And in fact, if you look at the hottest new market model, which is Perplexity R1 1776, which is down on the left, that's one of the hottest new models. It's just a version of Deepseek that has been retrained. And so this idea of LoRa, that you can have millions and millions of models out there, even makes it's so exciting because there's the right model there for you.
Yeah, no, I think it is great. I think, and it's funny, as I'm thinking about this, I think maybe we should do a LinkedIn Live where we can show people how you can download this model, put it on your laptop.
Let's do it.
And run it. I think that would be, I'm sure it's out on YouTube, but maybe it's something that we can do to.
No, we should definitely do it. I mean, I show people every day.
Yeah.
Okay. Yeah.
That'd be
Should we
great.
go to the next lesson? I know we're running low on time.
Yeah. No, that's all right. We're doing well.
Okay, so here's the next lesson. Someone asked about how you manage it all. You need an operating system underneath that can take advantage, because lesson 4 is, man, if you are riding on this and there's a lot of competition, prices collapse. So this was the original pricing of Deepseek on the upper two, the blue bar and the purple bar, and this was the original OpenAI GPT-4o pricing. Man, it was an incredible bonanza. If you can switch models quickly by doing some automatic fine tuning, you don't need to get locked in, and you save a lot of money. Essentially, the price of this kind of inference just collapsed. And if you are quick off the mark, you can take advantage of those things.
Yeah. And do you think there's kind of, and we could call it the Rich-Tong law instead of Moore's law? Is there a Moore's law for AI, do you think, where it's just getting, cheaper and cheaper every 18 months? It seems like every 18 days or something. I don't know.
Yeah. Give a hats off to, oops, I just lose something here. Can you hear me?
Yeah.
Let me just say, I give credit to Nathan Myhrvold, former CTO of Microsoft. He said, imagine the future where all compute is free. It's just free like air, free like water, free, and then go build systems. What you should take away from this is, just imagine this stuff doesn't cost anything. What applications do you need in your business or in your home? And that's the way I think about this, because this stuff is rapidly commoditizing, which is great for everyone.
No, I think it is good. I think that, there's the other side of it. And then you look innovation, sometimes when you take things away, people, what is it? Necessity is the mother of invention.
Absolutely.
When you got abundance of something, then people don't have to code things efficiently or effectively. I think about the kind of the space race, right? And I was thinking about the amount of kilogram, the writing code.
Kilograms, yeah. Mm-hmm.
Kilograms, but also kilobytes on writing code that, I don't know how much memory kind of sending people up in the space, but it wasn't a lot. I mean, I think we have 10 times that on our iPhone today. And what happened is having that constraint actually made people more effective and created. So I wonder if, because we have that abundance of availability, are people just going to kind of make things and use a lot of resources? I think of that kind of, because like you, I have kids as well, and I want to leave this planet, in a better state than before. And so are we just using all this stuff up and creating stuff, but not really looking at the energy usage and impact?
Really great question, Steve. I mean, I think the impact of this is the cost of things are going to go down. The amount of electricity that's needed is going to go down, because the person who has things that use half the amount of electricity just have an advantage. So this is where the free market can really operate. In fact, all the stuff that I just did, I'll just give you some sense of it. So a typical NVIDIA GPU complex requires about 5 to 10 kilowatts of power. So I did all of the graphics and things you see on this on a 30-watt chip.
Wow.
So think about that. That is energy efficient, my friend.
Yeah.
So I think we all need to realize how efficient we can make it, because remember that all those 22 million people are working on something, and efficiency is one of the key things, because getting to run everywhere is what naturally happens in an open environment.
Yeah, no, exactly. Exactly.
Next slide. Let's move on to the next one, Steve.
Yeah, I see Zachary talking about 32 kilobytes of RAM and 72 kilobytes of RAM. So thanks, Zachary. You're out there doing research for me as I'm going through the LinkedIn Live. Zachary, if I've got you right, he's calling in from LA. He does a lot of work, and we met up, and they're doing a lot
he's great.
of AI.
Awesome, man.
So, excellent. Go ahead.
Okay. Remember all of that fine tuning stuff? It really works. So this chart, there was a model called Quen, and it basically scored originally about 39% on this particular test. And then Mr. Newsbang and Rombo Dog and Zeta Sexpic and Mazayar Panahi, I don't know if I pronounce that right, got to work doing that LoRa fine tuning, and they basically improved the score dramatically. It went to 47% with the latest one. So all of that fine tuning, all those people just uploading these models, that's what you get. So lesson 5 is this fine tuning stuff really works. And what it means for everyone on this call is there's the right model for you, for your application. You just need to be connected to the open internet.
And Rich, if I were on here and I wanted to kind of take a look, what resources do you use to go look at all the models and all the scoring?
Oh, it's a great question. So we cheat a little bit. So
Yeah.
we built a system, we call it the model farm. We actually automatically go through all of the new models that are published on Hugging Face and other places and just analyze them automatically to see how good they are. So otherwise you got to go to Reddit, you got to track Hugging Face. It's really a chore. Having this automated system, that's what's going to make these things possible. So at a big company like HSBC, impractical to do it any other way. You got to test it, validate it, make sure it's got the right stuff. So that automation is what our project that we call Orion, which is our AI operating system, it's one of the things it does. But otherwise, it's impossible. You can't keep up with 100,000 new submissions a day. You got to use computers to do that.
No, without a doubt. And just kind of for the listeners, the reason Rich keeps bringing up HSBC is because that's where I used to work for 20 years of my life, and now at Horizon X. But Rich, I got to tell you something, and I'll probably dig in after this a little bit more, but I did have a banking client ask me specifically for an application that can do this, and they're trying to bring it into a bank. So there could be a product opportunity on
let's
what
go
we
do it.
created, and we maybe do a subscription model. And if that's the case, everybody on this call heard it first here. So
yeah, there you go. I think that's a great product. It's one of the main reasons people want to work with us, because you need to be able to slide things in and out automatically.
Right. No, I think, and there's a lot of value in that. I had done a hackathon with a company called Digital Futures, and we did it exactly on this use case. And it was just amazing on kind of the ideas that the guys came up with on what they can do. So should I go to the next slide here?
Go to the next slide, my friend.
Okay, excellent.
We're almost done with our lessons. Here it is. Here's the model farm. I even put the slide in. So just to explain the way it works. So we basically scan Hugging Face, Open Router, and we do what's called a rapid smoke test, which is just to try things. And it's essentially automated benchmarking across small, medium, and large models. And then what we have is a system that takes the candidate models and then runs them in production in sort of shadow mode. So it's looking at a production workflow, just trying them to see how they're good, how good they are. You can think of this as sort of like the farm league in baseball. And then finally, we put it into production. We basically run them statistically. And what we basically do is we do spot checking. So we'll run small models if we think the thing is running well. If it's complicated, we'll automatically bring in the big models, sort of the big boys to work, but big models are expensive. So you can balance cost, reliability, and also response time, because the small models can run on your laptop or your PC, and they're really fast. And the last thing we do is, I always think of this as the old timers, the 45-year-old pitcher. We keep the obsolete models around so we can make sure that the thing isn't drifting. And so this kind of model farm system, I think, is going to be required to deal with all that open source goodness.
I think you have an opportunity here. This is just amazing, and it's great, and the way you've structured it. So that's great. Just a reminder for everybody, I think we've got about 10 minutes left. If you have questions, drop your questions into the chat, and we'll go ahead and make sure we try to get those answered. Maybe do rapid fire answers. At what point, Rich, shall we go? I know you've got a demo. Should we go into your demo, or should
why don't
we
we just go to the last one, and then we'll do a quick demo, because we're almost done. Okay, let's go one more slide. So here's number 6. The small agent thing is a big deal, because a single big model is hard to control, and you'd rather have 10 small agents that don't need state-of-the-art performance or lock-in, and then you bolt them together. So what this chart shows is, let's see, 15 or 20 models. They're all connected together. That's in the bottom. And what we can do is we can run many, many small models, and you bolt them together. And 90% of it can just run on your own private PC. And in the back, I know there may be some programmers here. The way you connect them together is just with a text file. So you say agent 1 does this, agent 2 does that. And that's how you get this tremendous efficiency. So again, the model is only the start. You need a way to put them all together. And now why don't we go to the demo, and I'm going to show you the thing in action. How's that sound, Steve?
Excellent. Sounds good. I think we've got your screen now. Yep.
Yep. So what you see here, this is all, by the way, this is all running locally. So everything that you see here is local. And when I click here, you can just see how many models there are in the world. So these actually, my laptop connects dynamically to the cloud, right? And then all of these models are available for me to try, and our system can try automatically. And there's a lot of them, right? And see, that's why I needed this automated system. If we come down here a little bit, you'll see these models. Can you see this? It says Quen 2.57B, 7.6 billion. This model just runs on my machine. Wow. And when I click on this, it's just going to operate. So I'm going to click on a model called Deepseek right here, and I can ask it some questions. Hang on. Let me just give it a question to ask. So we use a smoke test that basically is an inventory scenario. So just to show that for a second, I'm just going to copy this. It's a very simple scenario. And what it does is it asks the system, hey, I've got hats and gloves. Here are the financials. Tell me what the financial analysis should be. And this is the way that our specially trained system works. With just some simple English language, you can just get right to it. So if I get to Deepseek, I'm just going to start Deepseek up right now. Sorry. And just start R1. How about the 14 billion parameter model, just for grins? When I click on this, I'm going to put this in. And when I hit send here, this is not going to the cloud. This is just running on my local machine. And so now what it's doing is it's loading the model up. It's now doing what's called thinking. So it's going to start with, how am I going to even think about the problem before I give an answer? And this is what's called a reasoning model. So it's actually in the middle of, well, what do I have to do? And it actually runs through a dialogue. It's actually talking to itself. I sometimes do this. Here's how I think about the problem. Let me apply this to both products, blah, blah, blah. And you can see, by the way, this is running very fast. It runs basically about 15 to 40 tokens per second. Oh, we read at about 6 tokens per second. So it's way faster than we can read. And it's rapidly trying to figure out, how should I answer this question? The questions were basically, tell me what I should do with my hats and gloves.
So again, as you're doing this, just are you? So you're not training the Deepseek model online because it's not going online. Are you training your own model that's running on your laptop?
Exactly right.
Oh, so you are training it. So the smarter your model gets based on the interaction with you. So how do you keep that going? So let's just say you get a new laptop. How do you keep that model there?
Good question. So there's basically this particular model, you can actually take the data that it has and then just copy it somewhere else. So we have a whole collection of specialized models that are running. And what it lets you do is, whether or not it's one laptop or 1,000, you can just duplicate it everywhere. It's just like regular software. You can think about like Office. I need to download something to get it. That's all we do. By the way, you see that it's doing a lot of reasoning thinking. And one of the big innovations of Deepseek was it actually talks to itself. It literally, you're not going to see, this is what's actually happening internally. So we're sort of ripping off the shrink wrap to see what's actually happening. And you can see, I'm not going to go through it, but it actually backs up and says, oh, maybe this isn't right. Maybe this is wrong. Maybe this is right, just like real humans do. And these reasoning models, that's really been the big innovation in the last 60 days, really work. And so you can see it can spend a lot of time doing what's called inference time computation. So it's not a big data center training. It's actually grinding through trying to figure out the right answer. And so it's gradually moving its way through. And it can spend, by the way, if you're doing deep scientific research, it can spend days doing this. Just looking at web, doing this and doing that. In this case, it's probably going to spend 2 or 3 minutes because it's sort of a modest question. And the point of this is that, look at all the things that I can do. I've got all of these different models available. We've been doing all kinds of testing. This has all been done locally. So Steve, this is what I was doing on airplanes instead of just watching movies. Wow. You can actually do all this development. So we have things in fashion, building management. We have a wealth builder application that we're doing from somebody, and I can just develop this all on my laptop. By the way, it's grinding through inventory calculation.
You're saying I can do this stuff instead of playing Sudoku, and I could be more.
Well, you got to play Sudoku because that's good for the soul, but it is very important that you can also grind away doing this. And so basically, for those of you who are in the sales business, it actually understands what daily sales inventory is. It understands very specific manufacturing data. It understands how many days it takes to sell. And so what it's doing is it's actually got all the information on the internet already ingested. We did a little training to make it a specialized retail application, and now it's grinding through the logic. The result is a much better response. And you have this trade-off between instant response and a better response. Now, this is doing a lot because I've told it, really be sure you're right. And so you can have the quick answer, but we know the big problem with AI is hallucinations, right? It doesn't do the right thing. So wouldn't you rather wait a minute or so to make sure you got the exact right answer than to quickly spew out a wrong answer? That's one of the things I always teach our kids, right? It's better to have the right answer than just say something.
Yeah. No, I think this is great, and I think it's impressive what can get done, and being part of a large organization, 250,000 plus people, and in so many different countries, this technology in the right hands with the right people could really move mountains.
Yeah,
right.
And I think we should do a training session to get everyone up to speed, because here's what's actually happening. Most of the time you don't see, you just see the computer's thinking.
Yeah.
And in a minute or so, it'll actually come out with the exact right results. So just to go ahead, this is the actual answer. And it says, okay, you asked me about financial analysis. It actually just took that little data. Here's the inventory calculation. Here's how I calculated it. Here's the units sold. Here's the ending inventory. It calculates the unit financial analysis. What's my unit gross profit? It knows the key ratios like gross profit margin, total sales, and we tuned it so it actually will give you the monthly profit. It also tell you the key sales ratios and cost ratios, and actually goes ahead and makes some recommendations. Just so you know, it's a lot to go through, but basically hats are doing well, gloves are not selling, and they're losing money. And so it's actually recommending thinking about doing things, basically getting rid of gloves and focusing on hats. All of that work happened just on this laptop.
I think that's amazing, and that's great that you ran through this, and I'm sure a lot of people will definitely watch this again. I saw Ahmed write that it's a great idea to have a session about how do you download the model on the computer, and kind of work that. So, Rich, I'm going to stop sharing screen. It's just going to go back to the video. I think we only have about 3 minutes left. I want to kind of just let everybody know, okay, how can they get involved? What can they do with us? Because I could tell everybody the reason I'm really excited and working with Rich, and the reason, right now I'm in Dubai, I'm in the process of setting up a corporation here, is there's a lot of opportunity out there leveraging AI in this Horizon 2 space, understanding and seeing kind of what Rich and team have built, true products that are being used by clients are pretty amazing. So if any of you guys on this call have interest or want to dig in deeper, by all means, send me an email or drop Rich an email, and we can definitely work with you. We, the one thing that I did learn is you want to make sure you can deliver on kind of what you're talking about. And that's why having Rich on the team makes me feel incredibly confident from an AI perspective. I was always confident from a transformation, a digital transformation, an innovation, even a quantum computing perspective. But the AI kind of always eluded me because I didn't have that expertise, but now kind of partnered up with Rich, we do. And so anybody on this call that would like any support based on what you saw or doing that, by all means, give us a call. I think we can have a big impact. I don't know, Rich, do you want last minute? You got the last word.
Hey, just reach out to Steve and we'll get you set up.
Yeah. Rich, thank you very much. This was definitely very informative. Every time I listen to you, I realize how much I don't know and how little I do know. I usually consider myself a pretty technically sound guy, but we learn a lot. We definitely, if you guys want to drop in the notes what you'd like to see next, I definitely will have another session with Rich. And we'll see if it's about how do you download it and put it on your laptop and get it going. I'm sure it could make us all very effective. Rich, thank you very much for your time. I really appreciate it. Everybody on the call, thank you around the world, and looking forward to seeing you guys at the next LinkedIn Live. Have a great day, everybody.
Have a good day. Take care. Bye-bye.